All right, aloha, AMOS. How's everybody doing today? All right, you ready for fun-filled excitement and adventure here, talking to Air Force Research Lab and Space Systems Command? Yeah,
yes,
all right.
We are.
Very cool. So it's so great to be back here in physical presence here at the conference. I know the virtual, although we accomplished it, just wasn't the same. So great to see familiar faces, familiar organizations, and I wanted to thank the Maui Economic Development Board for setting up this conference in a time that is very challenging. So we're going to talk to you today about preparing the United States Space Force for the second space age. Over to you, Colonel Felt.
All right, there have been a lot of changes at the conference, of course, and if you think there have been a lot of changes here, just look in outer space. A lot of changes happening up there too, and even more to come. So we are in the middle of a second space age here. It is the key things to note about this time around as compared to the 60s, but this one is being driven by economics. Folks are doing new missions in space and old missions in space in new and innovative ways, and that is driving all this commercial activity is what's driving the second space age, not necessarily the role of government. In terms of space domain awareness challenges, look just at the number of objects that we're going to have to deal with by 2030 as compared to today, 100 times more. Shoebox-sized things, all kinds of things from very low Earth orbit all the way to Cislunar and beyond. So our space domain awareness challenges are paramount, and we must do it to enable this second space age driven by economics. In the bigger sphere of economics, we are in a global competition, not just in the military domain, but in the economic domain with China and Russia. The estimate shown here will show you that the E7 is going to be about the same size as the G7 by 2015, and then by 2040, double the size. So this is, in the global economic context, space is an important part of this. Space economy, also growing incredibly, estimated today at about $400 billion, growing by 2040 to $3 trillion. And by the way, go look at the Chinese estimates of what the space economy is going to be, even higher than this. So again, we've got certain dynamics happening in the world in terms of the economy. We've got certain dynamics happening within our industry in terms of the economic growth and the new missions that are coming. And those are driving our space domain awareness challenges. Lunar missions. There are now, if you go out and look at all of the people that have planned missions to the moon, there are 100 missions to the moon that have been planned to various different degrees. Probably some of that is people in their garage dreaming of going to the moon, but a lot of those are real and are already happening. So you've got some of the moon missions listed up there for 2021, 22, 23. They are happening now. It is very difficult, and I'm sure I'm preaching to the choir here, to track the positions and especially the intentions of objects that are operating up in cislunar space. And so that is one of our primary space domain awareness challenges. And with all this commercial activity, again, this is happening whether we track it or not. So this is our challenge, is to figure out how we're going to deal with this. Now, this way to think about this that we like is to think of these are the space lines of commerce, or the space lines of communication. And if you map out all those missions that are planned for space between now and 2030, you will see that you have tons of LEO activity with the proliferated LEO actions on the thousands of satellites going down there, and you have a lot of activity going up to the moon. And if you map all that out, you might call these the future space lines of commerce. Well, we've been here before. All right, when we expanded in the maritime domain, when we expanded out west, we had lines of commerce. Now, the key things about this that were successful in those other domains, and what we're going to postulate for you here today, is that everybody has to do their part. All right, commercial activities are leading this because they have the profit motive to go out and make money in space. But the government has a very important role to not only get in the way of that, but to enable that with certain intelligent and proactive choices along the way. Now, fortunately, we don't have to make this up as we go. We've got a lot of lessons that we can learn from history. And so one of the things, since we're sitting right here in Hawaii, that we think would be a great historical lesson for today is to look at how Pan Am crossed the Pacific.
All right, next slide. So General Raymond, our Chief of Space Operations, said space is hard. He is exactly right. It is hard, but we've been there before. So as a government partnership with the industry, we crossed the Pacific in the 20s and the 30s and the 40s and made significant strides both in the industry and the aviation industry for this. And we're going to take you a walk through history and talk about Pan American Airways. Next slide. So Pan Am, the day of the Clipper ships and the Clipper planes, those flying boats, was really challenging for the environment. Aviation wasn't as mature as it was today. So there were a lot of governmental things that needed to be done to expand that industry, and there were also things technologically that had to happen. We had to get long-range communications right. We had to get navigation right. We had to do weather forecasting across the Pacific in very remote areas, very challenging. One of the great examples is Pan Am. Their first actual route was from Key West to Havana, Cuba. So 90-mile flights. So a short little hop really jump-started an industry, and you can see that. But on one of those first flights, they had a real bad problem. So weather came in, they lost an aircraft, and that 90-mile flight, they turned into 300 miles off course, and that plane crashed in the Gulf of Mexico. So Pan Am, as they were developing air travel, learned a lot of lessons, and sometimes the hard way. They rescued the crew, and it worked out, but very challenging. Next slide. So Pan Am, as they were growing, one of the biggest routes was across the Pacific to get all the way to China and support the industries in the 30s. But aircraft industry wasn't up to par yet. They haven't developed the aircraft needed to fly the longest leg, which was from California to Hawaii, right here where we're standing. 2,400 nautical miles, challenge for the industry, but Igor Sikorsky developed the flying boat. From that, we had Glenn Martin develop his version, and then eventually these giant, large flying boats called Clippers, and the China Clipper developed by Boeing really expanded the art of the possible in the technology. Next slide. This is some maps of what they did. They were establishing forward operating bases all across the Pacific. So the island of Guam, the island of Wake Island, Midway, etc. They had to establish these bases. They had a ship, a large ship called the New Haven, went out there, built piers, built shelters, buildings, comm systems, power generation systems, all across the Pacific, developing these lines of communications, not unlike what we're trying to do in space today. And then there was an industry on it that developed with the government. So the US Postal Service established a business environment that was conducive for having mail and making sure the rates were profitable enough that they could actually support the operations. And so that was a partnership. Pan Am developed, if you look at the top left picture, that's actually of a China Clipper and the inside. So they've got folks working communication systems, new over the horizon, comm, UHF systems. They also had navigated by sextant, so using the stars as they cross these large, vast openness of the Pacific. They developed the first, long before Loran was invented, they invented navigation using a closed-loop antenna for direction finding and the equipment to do that. In addition, you see the New Haven there pulling up to a lagoon, and they're establishing that beachhead. Think of beachheads, what we're trying to do in space. So very analogous here. Next slide. All right, so why is this important? So we had these lines of communication, logistical supply lines all throughout the Pacific, but in 1941, when the Empire of Japan bombed Pearl Harbor, they simultaneously tried to take out every single Pan Am station within the next 2 days. So they really broke up those lines of communication and tried to disrupt it, but we knew that was going to happen. So all those pilots and all those ground crews actually had secret orders to become part of the Department of the Navy if war ever broke out. And it worked really well, and throughout that, there was a long history of service for those pilots. And then something you might not know is Pan Am actually trained almost all of our navigators that were in the service during World War II. The Doolittle Raiders were trained down in Florida by Pan Am. So this is really a partnership with industry, whole of government, and the military. So over to you, Eric.
I love the stories about how we solved the technology challenges to get across the Pacific, and there were many, many of them. And since we love hard problems, we are also going to have great fun solving the technology challenges to get to space and for the development and human colonies in space and what the future vision holds. So what's AFRL's role in this? Well, we love hard problems. We love technology challenges. We love working on these things, and we love working on these things with partners in industry and international partners. So some of the things we've had to do so far to do our little role of advancing the ball is, first of all, how do you talk about these things? Conceptualizing the problem, and that's part of what we've seen here with some historical analogies. But the fact of the matter is, as you get above the geobelt, there's different physics, there's different challenges, different technologies needed, and there's different nomenclature and mapping that's needed. So we've done a few things already, like put out a primer on cislunar space that at least gets people talking about it. We actually prefer the word XGEO as a multiple of geo instead of cislunar, because cislunar is near the moon, but we actually care about the whole 4 pi steradians that's out to and slightly beyond the surface of the moon, because that's where the commercial activity is happening. That's where the potentially dangerous adversary activity is happening. So that's what we need to care about in terms of space domain awareness. So these are a few of the early things that AFRL was able to do. In terms of space domain awareness, we've already talked about many of the challenges, but it is the foundation for navigation. It is the foundation for safety and protecting and securing the domain. We have a couple of experiments, one called CHIPS, one called D2S2, that'll start to get out near the moon and start performing some of these activities, but that's just the start. All right, the vision in space domain awareness is to know everything, everywhere, all the time, in real time. It's really as simple as that. And by everything, we mean everything of interest, okay? And everywhere, we mean wherever that is happening, wherever activities are underway. All the time, we're talking about persistence so that nobody can hide from our sensors, and then in real time so that we can close the OODA loops when we need to attribute or conduct space warfighting if called upon to do so, and thereby deter it. So that's the vision in space domain awareness, but we're a long way from that. And so we need to get started on some of the technology enablers to make that happen. Aids to navigation. GPS sort of works out near the moon, but we need to do a lot more testing and analysis about that, and it isn't enough. So there needs to be other ways to navigate, with the ways that NASA has done it in the past, or as well as new ways that are being investigated. All right, space logistics. Turns out, one of my favorite quotes of one of my researchers is that a small sat in LEO is expendable and replaceable, but a small sat near the moon is a national treasure. And there's nothing further from the truth, all right? The further you get away from the Earth, the more valuable replenishment, space logistics, servicing, refueling, all of those capabilities are enablers to allowing us to go beyond GEO and for the Space Force to operate beyond GEO. So now we have applications of why we need these technologies that have been postulated and slowly matured over the decades. Another example of a new mission that can now be done from space, although the idea is not new, is solar power beaming. All right, Jerry O'Neill wrote about it in 1970, okay? But now we have the technology to directly convert solar energy into RF energy and deliver power on demand anywhere on the Earth. Now, with climate change and the need for alternative energy sources, we have the need for it, we have the technology for it, and that's opening up new capabilities in space. So that's just one other example of the kinds of new technologies and new industries that are opening up in space.
Great. So really cool stuff that the Air Force Research Lab is working on. But what we're doing in Space Systems Command is to be able to catch all those great ideas and new technology and transition those into programs of record. I'll show you real quickly here. We have our LDPE, so long duration propulsive ESPA rings. They're getting very popular and a great way to experiment and demonstrate new technologies and prototypes on orbit. And we're using those things today. So all of these experiments on the right side of the chart, these are prototype energy detection, energy charged particle sensors that we want to proliferate to future constellations. We have a wide variety of these with different capabilities to understand the space weather and if anything does harm to our spacecraft. We also are working with Air Force Research Lab on a predictive system called SPEAR to do anomaly resolution and really determine what happened to your spacecraft on orbit? Was it actually an overcharging event or some other phenomenology or a micrometeor or something else that attacked it? So lots of things, very important, that partnership to bring science and technology to real prototypes that can go on to operational systems. Very important. So next slide.
All right, so we've talked a lot about the new missions in space, these space lines of commerce, what this means for the Space Force, that these are emerging new missions. And we've talked about how AFRL and SSC need to get started now on the enabling technologies so that when the Space Force has that as their mission, they will be able to protect and defend the space lines of commerce. That economic expansion is happening whether the DoD wants it or not, all right? But what we can be is a good partner and do our role to enable it, to protect and defend, and partner with industry to make sure that that happens and make sure that that is US-led activity in the way that we want it to be. So these space lines of commerce are very important and they're rapidly emerging, and this is part of the defining moment of the second space age.
Yeah, and history tells us that we can do it, we've done it in the past, and that we should be getting ready to do it now. The military is no longer driving the space domain. We've got a lot of venture capital funds going in there, a lot of industries. Great to see some of the videos earlier on some of those rendezvous and proximity ops. So our goal is to leverage that and really help protect space and defend the US and hopefully prevent a war from ever outbreaking in space. So.
And that none of those things are going to be easy. All right, significant advances in science and technology are needed to perform space domain awareness from VLEO to Cislunar and beyond. And we have some of those things started, but we need your help. So the third bullet up there is really helping us get after the significant technical challenge of expanding our domain of operations and being able to operate in this as a contested, potentially warfighting domain. So we need your help on the science and technology. We have some great ideas and some great things underway, but especially above GEO, we've got a lot of technical challenges and we're ready to get after those.
Okay, one more slide before we go to questions and answers. But hopefully, I want to leave you with a cool story too. Historical story. So back in 1976, September 17th, they rolled out the Space Shuttle Enterprise. And then you see a lot of folks in that foreground there. They were wearing innovative clothing at the time. So, and then let me point out in the brown leisure suit, that's Gene Roddenberry, so the creator of Star Trek. He was actually a B-17 pilot in World War II, flew out of Oahu. And then he was also a Pan Am Clipper pilot. I wouldn't want to fly with him. He crashed 3 times, survived each one, and then the rest is history, inspiring the generations upon generations in space exploration and space travel to boldly go where nobody's gone before. So thank you. Thank you for the time, and we'll want to open the floor to your questions.
Thank you very much. Can you put up how to answer a question? There we go. There we go. We have some folks who are already sending in questions. So
wonderful.
We're going to stump the speakers.
We can't wait.
So the first question we'd like to ask is, what is the biggest technology gap you see to be solved to be successful? Biggest technology gap.
So I really don't think a lot of the challenges we have are technology. They're actually policy and getting things to work together, like data sharing and so forth. So I think if we can get those things right, those technology solutions will get there. There are some challenges I know the AFRL is investing in long term, but policy, processes, procedures, how we do things, and share data and information tends to be the biggest challenges as I see on the horizon. And then classifications of different missions and so forth. So those, I think, are our biggest stumbling blocks, and we're working hard to fix those. But what about technology, Eric?
So I totally agree that our biggest near-term challenges are on the policy front, but we do have a lot of significant technical challenges too. And so the way I like to think about it, and I already phrased it this way, but if you want to know everything everywhere all the time in real time, looking at it that way will identify all kinds of gaps that we cannot do today. And then how do you get after those gaps is defines the technologies that you need. One of the most important ones and something that we're working on is autonomous swarms of spacecraft, all right? This has been a technology that's been very effective in the air domain. There's no doubt it's going to be effective in space too, but it's going to be extra challenging, and that's one of the technologies that I think we're going to need, especially as we go above GEO and farther away from the Earth. And you cannot have operators flying thousands of satellites. You've got to have autonomy, new ways of operating to do that. I think we have a lot of technical challenges left there that we need to start eating away at.
Yeah, that's great.
Another question that's First Lieutenant Liberty Shockley here, who gave a talk yesterday, she came up with a really good question, and that is, does our current acquisition system allow for an industry partnership like we had with Pan Am?
Oh, that's a great question. So actually it does. So we do have tools that we have to follow the law, right? We have to create a fair and level playing environment for all the companies and corporations. So there's laws we have to follow, but we have lots of different things like partnerships. I know AFRL and other organizations, we establish CRADAs with industry and academic institutions, and we can share and collaborate. It's also important for us to invest in those technologies and do the seed corn to get the industry moving to have military useful applications. I know we just did a recent Space Pitch Day back in August where we awarded $35 million to lots of small companies trying to innovate within the sphere. I know you were on that panel with me, Dr. Cooley, but it was great to see the enthusiasm in space and going after it. So you can do those partnerships. You just have to be savvy and understand how you get those things done. And then especially with the rising threats to our space systems, critically important. And that usually helps us with the bureaucracy.
I agree. We have all of the building blocks and enablers that we need to do it, but we have a lot of cultural challenges to getting after it. I think the number one thing the government could do is start buying more of the emerging commercial goods and services that are out there. By buying more, we are signaling what our value function is, and then the capital markets can respond to that and meet our needs much more effectively. So if we, for example, start paying for, $1 million a gallon for fuel at GEO, if we start, I'm just throwing out examples here, if we start paying $1 million a pound for debris cleanup, you can see the kind of commercial goods and services that we could buy and that we want to buy. And I think if the government would actually start doing more of that and telegraphing our future needs in an economic market-driven way like that, that would drive all kinds of good behavior from the commercial sector. So that would be my number one recommendation. And there's nothing stopping us from doing it except the cultural inertia and resistance that we deal with every day.
But it's great to see the space industry taking on new challenges. I haven't looked at my phone to see how successful Inspiration 4 was, but tourism. Can you imagine a day where you can be a tourist and pay, it's probably a lot of money, but to land and walk on the moon, walk up to where Apollo 11 landed, almost as a museum, and see those footprints? That day is coming. It's not far away. And you definitely want to make sure that we're tied in to take advantage of all those advances on the commercial sector has. So, all right.
Excellent answer. We haven't been successful at stumping you yet. But I got
harder questions. Come on, you can do it.
Get some involving math, and then I'll let him do it.
Okay, so the next question from the audience is: for the challenges of XGEO, do you see SDA or precision PNT infrastructure as a more high priority challenge over the next 5 to 10 years?
I see all of those, really. I think it's really important to get all of those technologies. Those are the same things that Pan Am set up when they were out there: communications, navigation aids, weather. I didn't talk to you about, they dropped aluminum powder out the side of the aircraft, red aluminum, and they watched it as it fell to the ground, and they could figure out the winds aloft. They radioed that to other pilots. So they would know what the weather conditions were and if they had to turn back before they finished that flight. So you're seeing the same things today. So very interesting. What are your thoughts on that?
What we've found as we lay out our future programs at Air Force Research Lab is that this space domain awareness mission drives all kinds of other needed technologies. And so if you can do SDA, which is the foundation for space warfighting, then you can do everything else that you need to do too. And in fact, it'll mature all those technologies along the way. So space domain awareness from VLEO to the moon is what I would lay out as our most needed technical challenge, and that we need to get after with commercial, government, all of us. And then by doing that, we will have to cross some other technical hurdles along the road, just like Pan Am did.
Outstanding. I have one question for you to finish up this session, and that is, very simply, we've been looking at, with Dr. Joel Mosier, at what the future holds, trying to peer into the distant future. So what is the U.S. Space Force role in that cislunar environment, ex-geo environment, in the year 2060?
What do you think?
I already talked about protecting and defending the space lines of commerce. I think that's exactly it. It's the same as the Navy's role at sea, where they protect and defend the sea lines of commerce. As you have activity in space, and you have more activity in space, you're going to have people doing nefarious things in space. Even if they don't have any nefarious intention, you're going to have astronauts that need rescuing. There will be all kinds of missions.
Even space pirates someday.
There will be missions that the DoD will be called upon to do. And so I believe it's protecting and defending those space lines of commerce as they emerge, and that the DoD has a role of doing that with our international partners. What's lacking, as compared to the other domains, is a lot of the rules of the road, the ground. How do we work with others? What are the norms of behavior? That's why you hear so much talk about that as an enabler for these future missions. But that's what I think we're going to be in the future, and so that's why AFRL is working on these technologies now, so that Space Force is ready when we're called upon to do that.
Yeah, we need to launch more experiments per mission, per time. You saw the LDP rings. That's a great platform to attach a lot of different experimentation to work out those kinks and technologies. But our goal is to launch as many of those experiments, work with industry partners, work with our allies to get more experiments up on orbit to solve those needs, and all those things you mentioned, the PNT, the comm, the weather, understanding the environment, understanding what your adversary is doing is really important. So, all right.
Outstanding. Let's thank our speakers, and thank you very much.